Hello everyone, welcome to Data Discovery. At this video, we are going to see the concept related to normal distribution. So, what is this normal distribution and why this normal distribution comes into the picture, and how we need to deal with the normal distribution and the formula, and how the formula comes into the picture, and then the most important code, etc. things that we are going to discuss at this video. As in this channel, in the data discovery, we are coming across all the data science concept. Okay, so I hope this video will be definitely useful because this normal distribution, this NT comes into the picture again and again. First, let's understand what is this normal distribution. So the normal distribution, also known as a Gaussian distribution, a Gaussian normal distribution, we used to say, yeah, it's a probability distribution that is commonly used in a statistical analysis. It is a continuous probability distribution, the most important part. It is a continuous probability distribution that is symmetrical around the mean with a bell shaped curve. So, this is something related to Gaussian normal distribution. Okay, so let's get started with it. First, the y-axis contains all the probability values of the particular input. This is all my x input. So over here, it is a symmetrical. Okay, this is symmetrical. Symmetrical is nothing but uh, it's almost might be symmetrical in my diagram, but actually in normal distribution, if you will cut in between, it will be in the symmetric format. Okay, but in my picture it might be not symmetrical, but actually it happens. Okay, this, it's nothing but the normal distribution. Okay, over here, if I need to say, I will be coming across the properties, but still I will say the mean values, the median and mode will be same, not almost same, will be same. If it is same, then it's called as a normal distribution. So whether the distribution that following normal or not, there are various kind of the plot. First one is by plotting a histogram. If you will smoothing the graph, then you can easily understand it's following normal distribution or not. Second, by using a QQ plot, there are various kind of the distribution to find whether this data is following a normal distribution or not. Okay, this property is related to it, I will be coming across it. So because before that, I need to clear some more concept. Okay, now the value that you can see it over here. Okay, it doesn't touch at all, it doesn't touch at all. It goes on infinite, might be touching at infinite, but it goes on infinite values. Okay, the x value is nothing but the infinite value, you can say. Okay, over here, this region that you can see it over here, the region that you can see it over here, it's nothing but major number of point lies over here. Major number of point lies over here. You can give very good example. It's nothing but height of the people. So major number of the height of the people lies in this region. There are very less number of people whose height is quite small. If I'm speaking about adult, about 18 age, about 18 to 60 age people, if I will be taking the data and if I will be plotting the graph over here, so at that moment I can get the major number of people lies in this area only. There are some kind of the people whose height is very less, like over here it will be lying it over here. And there are some kind of the people, very less number of people whose height is quite more. Like we can take it of example Great Khali. Okay, that it's a not type of the outlier that we can say. It might be outlier if I will be calculating the actual distribution of the data, but it will be quite away from the mean. Okay, so this will be the good example for the height, even weight also. Okay, if the people lies over here, then it's nothing but they are obesity, they are in the obesity form. If the people weight is lying over here, it's nothing but the underweight. Okay, it's overweight, underweight, and it's the correct fit weight. So we can describe the data based on an even IQ. So major of the people, the IQ it lies over in this part only. So there are very less number of people whose IQ will be in this range. Okay, so these are, it's nothing but related to normal distribution, how actually it works, and then lots of the point near the mean and very few far away. So from that you can get the concept that lots of the point are in the near the mean. Okay, if this is my mean, so lots of the point it will be my near the mean, and very few point will be away from the mean. So this is nothing but related to normal distribution. So the normal distribution, the ND, is categorized by two parameters. Okay, the parameters is well known. It's nothing but by mu and sigma. Okay, the sigma is called as a standard deviation. The mean represent the center of the distribution. Yeah, the mean represent the center of the distribution, and the standard deviation represent the spread of the distribution. What will be the spread value? Okay, how much you need to disperse. So based on the dispersed value, the sigma it denotes. Okay, so the normal distribution is always centered on the average value. Okay, if it is centered on the average value, then only it's called as a normal distribution. The vice versa part also. Okay, so as I've said, the normal distribution is well known by the mu and sigma. Okay, so by using that we got the formula for it. This is the formula that we will be using in recurring format in the data science stream. But as of now, there are very inbuilt library. By using that, we can directly convert into a normal distribution any of the data. So we will be not using in the project. So anyways, it will be inbuilt. So actually how the formula looks like, so that's what it represent over here. Okay, it's been constructed by the sigma and the mu, and this x is nothing but the data point, and this is nothing but the exponential value. So y is nothing, y is equal to f of x. It's nothing but y is the probability density of x. Probability density of x, it's nothing but over here that I have distribution, probability distribution of the function. Okay, see the probability density of the function in which the y values occur. So there are certain properties that we need to discuss, that we'll be discussing it. But before that, one small thing that I need to say of the empirical rule. So before starting deeply related to empirical rule, we need to understand the standard normal distribution. So the standard normal distribution, the SND. Okay, so before learning standard normal distribution, we need to learn the Z score. So after that only the empirical rule that we'll be understanding it. But still I'll just give one small recap that how the standard normal distribution actually it follows. Okay, we used to say the standard normal distribution as 68, the empirical rule, 68, 95, 99.7 percentage. Okay, the normal distribution is also called as the empirical rule. It follows the empirical rule, and the rule is called as a 68, 95, 99.7 rule, that states that approximately over here I'll just mention 68 percentage of the data falls within one standard deviation. Okay, one standard, it's nothing but mu minus sigma, mu plus sigma, like that it comes. But I will be discussing once we are completed with the SND. But before that, just some thing of the empirical rule. What is the empirical rule and etc things, we'll just see it off. And then after the, as I've said, the 95, so 95 percentage, so 95 percentage of the data falls within the second standard deviation, two standard deviation. Two standard deviation is away from the mean, and the 99.7 percentage of the data falls within three standard deviation. So this is how the data looks like, it's three standard deviation. Okay, we in x data point we used to say that mu plus sigma mu minus sigma, mu plus 2 sigma, like that we used to represent that. But as of now, I'll just given a small thing that related to how empirical rule actually looks like and why this empirical rule comes it off from the normal distribution. So once we are completed with the standard normal distribution, at that video itself, in my coming video, I will be discussing about the standard normal distribution. So for that, the empirical rule I will be discussing more deeply than this. So before starting with the code, I'll just give the small recap related to the properties. So here are the properties for the normal distribution. The first property is, it's nothing but the symmetricity. Okay, it's nothing but the symmetric values. Okay, I'll just mention one normal distribution data. My normal distribution doesn't looks actually like a normal distribution, but somehow it's looking okay. The normal distribution is symmetric about its mean, which means that the probability of observing values about the mean as probability of observing a values below a mean. The bell-shaped curve of a normal distribution reflects the symmetricity. As we have discussed previously, it's shown the symmetric distribution of the data is formed. Okay, the bell-shaped curve is a very well-known word for the normal distribution. And the second property is called the measure of central tendency are equal. Central tendency, it's nothing but mean, median, and mode. So in which the three things will be equal in the normal distribution. If it's equal, then only it's called as a normal distribution. The vice versa part that we can say. So in the skewness, in coming videos we will be coming across the skewness, the positive, the negative skewness. Okay, so based on that, the mean, median, mode will be affected. So the mean will be greater than median, positively, negatively skewed. So like that kind of the distribution you will be getting, like something like this is positively skewed, this is negatively skewed, something like this type of the data that you will be coming across the positive and negative skewness. So at that moment, the mean, median, mode will be affected. The central tendency will be not equal as like a normal distribution. And third thing is the most important, that is nothing but area under curve is equal to 1. So it's nothing but my lower limit and my upper limit of the data. If I'm finding like whatever the values is, like from 0 to 1, whatever. Okay, it's not the actual value, but I'm just giving an example. So based on that, if you will find the area, you will be getting the value as 1. So whenever that we are converting into a standard number distribution by using a z-score value, so like if I need to find this to this area, so at that moment we used to represent from this to this, like from the 1 we are subtracting this part. If we are subtracting this part, then we will be getting this value, right? So based on that, we will be calculating. So at that moment we are using this one. So the properties is coming from area under curve is equal to 1 in normal distribution. So this all are the properties for the normal distribution.